A bus topology arranges all devices along a single shared communication line called the backbone cable, to which every node attaches via drop lines and taps. All signals propagate in both directions along this backbone, and only one device may transmit at a time, making collision handling essential. Early Ethernet relied on CSMA with CD, carrier sense multiple access with collision detection, to manage this. Bus topology was favored in the 1980s-1990s for small LANs because it was inexpensive, easy to extend, and required minimal cabling, but it suffered from signal degradation, difficult fault isolation, and single point of failure risk if the backbone broke. Today it is mostly obsolete compared to star and tree topologies, which dominate modern Ethernet because switches provide dedicated links, higher bandwidth, and no shared medium collisions. Ring, e.g., early token ring, and FDDI, and mesh are now uncommon, except in specialized or backbone contexts, while hybrid topologies combine elements, typically star of stars, in enterprise networks. Point-to-point is ubiquitous for direct device links, e.g., router-to-router, fiber uplinks. Bus topology still appears in industrial control systems, automotive networks, e.g. CAN bus, and some embedded systems, but not in general-purpose LANs. In those contexts, bus refers to the shared electrical signaling architecture rather than classic Ethernet coax, and it remains useful where deterministic timing, low cost, or simple wiring runs matter. Bus topology employs CSMA to regulate how devices share a single communication medium. In a bus network, all nodes are attached to the same backbone cable, meaning only one device can successfully transmit at any given moment. CSMA addresses this by requiring each node to listen to the line before transmitting. If the medium is idle, i.e., no carrier signal is detected, the device attempts to send its frame. If the line is busy, the device waits until it becomes free. Variants like CSMA with CD, collision detection, historically used in coaxial Ethernet, take this further by having devices monitor the line during transmission. If a collision occurs, two nodes transmit simultaneously despite the initial check each device stops, sends a jamming signal, and schedules a randomized back-off time before retrying. This mechanism keeps traffic orderly on a shared cable without requiring centralized control or complex scheduling. CSMA is used specifically with bus topology because the physical structure of a bus makes collisions both likely and difficult to avoid without coordination. Every signal transmitted on a bus propagates across the entire length of the cable, so any two unsynchronized transmissions overlap and corrupt each other. Unlike switched or point-to-point topologies, there is no dedicated path per node and no switch to arbitrate access. CSMA provides a lightweight, distributed method for all nodes to cooperate in determining when the shared medium is available. It reduces the frequency of collisions and ensures that devices can fairly compete for bandwidth while keeping the topology simple and inexpensive. Without CSMA, a bus network would be prone to near constant interference and unusable at practical load levels. A busmaster is an alternative arbitration strategy in which a designated device, or a set of rotating devices, controls when other nodes are allowed to transmit. Instead of relying on distributed sensing like CSMA, the busmaster explicitly grants the bus to one device at a time, eliminating collisions entirely. This approach is used when deterministic timing, guaranteed bandwidth, or tightly controlled access is required common in industrial control systems, embedded buses, e.g. PCI, VME, and real-time environments where unpredictable back-off delays are unacceptable. A busmaster is preferable to CSMA when the network must support time-critical operations, avoid contention overhead, or maintain strict ordering. By centralizing arbitration, the busmaster sacrifices some simplicity and fault tolerance, but it provides predictable collision-free communication that CSMA cannot guarantee under heavy load.